Do you have trouble remembering your passwords, or have you ever given away your credentials to someone who claimed to be your bank? Fear no more! We got passkeys for you. Passkeys are a way to log into websites without using emails or passwords. Well, kind of. Only using a device. Something similar to multi-factor authentication, but you use a PIN or a biometric authentication. Please note that nor your face, nor your iris, nor your fingerprint leaves your smartphone. Let's take a look at how passkeys work, but first, to understand how they do, we have to simplify some things. We will first take a look at the normal sign-in, and then we will proceed with the normal passkeys. For the normal login, you introduce data in a form, the data is sent to the web page server, then the server verifies if the user with such email exists. If it does, it retrieves some data from the user to obtain the hashed or encrypted password. It then uses an algorithm, or in other words, it makes further modifications to the password just sent, and then it compares if the modified password and the stored password are equal. If they are both equal, the server will typically send and set some data to the browser. That will work so that we can identify if the user is logged in or not. Then the browser can make some requests to the server with that stored data. And finally, the server can verify the validity and not expiration of the data, and that represents that the user is logged in. Now for passkeys, our OS generates two strings, one private and one public. The public is sent and stored in a server, while the private one is kept encrypted in our device, and sometimes in a cloud environment if we so desire. So, the public key is generated from the private key, and you can always verify that, but you cannot generate the private key from the public key. So as its name suggests, the public key can be shared, and the private key must be kept in your device, and you cannot share it, or you shouldn't share it. Now, to make a login, this is what usually happens. First, the login selects the option to log in using a passkey on a supported website or app. Notice that we say supported because not all websites or apps support this feature. The application makes a request to obtain a random string called challenge from the server. The server generates a unique challenge and stores some data to link the challenge to the particular user that requested it. Then it sends it to the requesting app. Once the challenge is received, the web app can display a list of possible accounts to be used in a certain website. After selecting the account, the user will be prompted to identify itself using a biometric security feature or a PIN, which again would defeat the purpose of using passkeys since you have to remember a key, but that's how you do it. Now, you have to sign in. Once the user approves authentication, the passkeys manager, in this case our device, plays the challenge using the private key. Notice that by using the sign term, we refer to do some transformations to the challenge. By using the private key as a form to modify the challenge, each key would yield a different resulting signature or string. The signed challenge, along some other information such as the website ID and other authentication parameters, is sent back to the server for verification. The server uses that stored public key that corresponds to the user's private key to verify the digital signature. If it matches, it confirms the user's identity. Then, in a successful verification, the server creates a session for the user and sends session data back to the browser or app, just like in the normal login, so that it can use that data to identify the user. Then the browser can make additional requests to the server using this data session, which will indicate that the user is logged in. Each time the user makes a request, the server checks for the validity and expiration of that data to ensure that the user remains logged in. Great guys, now that we entered the passkeys here at Passkeys Management for Bybit, we can add a passkey. Let's go, add a passkey. No need to remember passwords, alright. We will take a look if that's true. Works on all devices, ensures your security. Let's continue. To add that passkey, we need to verify our email and or two-factor authentication or the security measures that we already implemented into our account. Now let's click next step, and it will prompt us with the passkey manager. In this case it is Windows Hello, and I have to enter my password, and it says that the passkey was added successfully. Now let's try and see whether or not this passkey works at all, and if it is useful. So as you can see, these passkeys should authorize us to make some withdrawals. Now let's go to Bybit and realize that we have one passkey created here with Windows Hello. We're going to try to withdraw some USDT here and prove that it works or it doesn't. The passkey's alright. Let's go. Yep, everything's alright. And let's click submit. And it should prompt us with a passkey, right? Well, let's go to the verification to our email. Great, now it should prompt us with the Windows Hello, right? No, it does not. What's going on? Okay, so we're going to reload this to see whether or not we still have the Windows passkey. And we still do, but this doesn't seem to work at all. Let's try to log in back again, but nowhere do I see something like login with passkeys or something like that, right? Just mobile, QR code, and email. And here, if we press this, it takes us to the same page. Let's try to log in with a sub account. And it's the same, right? Nowhere do I see where I can enter my passkeys. And it didn't ever ask us for our passkey.
75 years later.
Great, so the other day I needed to log in into the account and I pressed the login button and now it prompted me with the passkeys that we were supposed to get right. Well, we get this quiz or puzzle first and we failed it. Holy moly, bros. And now we did it. And now it'll prompt us with the passkeys and perhaps it'll be alright. Let's say verify with passkey. And now it seems to work out, right? It'll log us into our account and that will be great because it means that it is working right now. And I assume the same would happen when we want to withdraw orders, but this is not the correct way to implement it, right? Because passkeys are meant to replace user credentials such as user emails or user names and passwords. So this wouldn't be another method for replacing that, but rather a multi-factor authentication. However, we will see the cons of this at the pros and cons section. Now let's take a look at the benefits of using passkeys. First, since the passkeys are tied to certain websites, phishing attacks should not trick the user and steal its data. Now, you do not have to remember your passwords. Well, at least that's what it seems like, right? Convenience, because we can log in faster, and also because we have synchronization across devices. Now for the challenges and considerations. Take a look. If one device gets compromised, you are cooked, bro. If you did not back your accounts, you are done, my dude, as well. We're letting electronic devices have access to authentication and custody as opposed to us being in charge of them. Also, we must be wary of security practices so that we not fall prey for such low-quality tricks. Backing up on cloud presents potential hacking issues. This feature is not supported in all websites. If your device is down for a certain period, you cannot use those services. If the website you use does not implement the passkeys adequately, like some services we took a look, it is basically useless. Now for the use cases for the weird people out there that still want to continue using passkeys despite the fact that they have a lot of disadvantages. People who need to handle a lot of accounts. People who often fall prey to phishing attacks.